guys for having me up here today. That was actually wonderful to have Aubrey introduce my talk. I now have a lot more things I can talk about, so that's great. So I must be getting old. I'm winded from having walked up 3 stairs. I'm in my 40s now. Hi everyone. It doesn't say it on my badge, but I actually come from Harvard Medical School. And I actually got tenure last year, which means now I can really speak my mind. And if the dean's watching this on the internet, forgive me. But what I want to say to you as a Harvard professor is that, and my thesis for today, this talk, is that aging is a disease and it is treatable. And I think we can do this within our lifetimes. And there are even clinical trials that are in progress that I'll talk about later, that are in progress right now, that have the potential to treat many different diseases at once. But I'm not standing up here, certainly as a Harvard professor. I don't think even tenure would allow me to survive saying we're going to live forever. I don't believe in that necessarily, not within my lifetime. But I do think Aubrey's right in saying that this is a question and a problem that most people ignore. If we have the first slide, have I got a clicker? Okay, these are my children. This is why I'm hoping to extend lifespan. I want them to have a great life, and I think that with the current technologies that I'm seeing come through the pike, and thanks to Aubrey, he's very gracious in saying that the company that I started is one of the leaders, this technology will allow certainly my children, if not ourselves, to lead vastly different lives than we saw in the 20th century. And they're very lucky for that. When I was in Australia, if you're wondering, my accent's Australian. When I was in Australia, I was a college student. I was like Aubrey. I was trying to shake up all what I thought were the zombies. We're all going to die. Do you know, this is really a real problem here. Do you not realize this? And they're like, yeah, just play your cards, deal it. And then what I realized was that we might be the last generation in human history to experience a normal lifespan. And I was pretty pissed off about that. Of the 10,000 or more human generations in all time, we're the last ones, and our children are going to be the lucky ones? Well, so I'm not as selfish as I used to be. I'm trying to help global health, as I'll talk about. But in those days as a college student, I really wanted to bring the future technology into today. And maybe, just maybe, if I and others worked really hard and Aubrey recruited more people into the field, we could have a big impact. And within our lifetimes, we would see these changes. And I'm here to tell you today that they have gone so much better. The technology is so much further than I really thought I would ever see in my lifetime. And it just blows me away. So let me tell you about what's happened over the last 20 or so years. You're wondering, what has this got to do with aging and drugs? Well, I spotted this button in the elevator on the way to my room just now. And it reminded me that, well, I'm not sure what this does, and I certainly don't want to press it. Bad things might happen. But my point is that what I try to teach my students and people I come in contact with all the time is try to think differently. Differently in a way that you might think is completely opposite. So Aubrey was talking about, let's just think, what if we could really do something about aging? What would that mean for the world? What would it mean for individuals? For example, in my lab, we used to have a map of the world that's upside down. And I did that just trying to jog the minds of my students to think differently. And it's very hard to do. I think it may be very difficult, if not impossible, to teach. But I want to do a little experiment here in this room and see if I can maybe make a little headway into the aging field. So I think that Aubrey did a very good job, but I'm going to try a different tack, in case you're not convinced yet that aging is something worth working on. And I ask this question quite often. I ask medical students that I teach at Harvard, how many of you think that aging is a disease? And so let me ask you, do any of you think that aging is a disease? I have one hand. So that's more than I get at Harvard, so that's good. I like that. Now, let me define aging and disease for you. If you go to the Merck Manual of Geriatrics, which we use at Harvard, you open it up and it says, a disease is something that occurs over time that is deleterious and horrible, and it happens over time to less than half of the population. Okay? What is aging? Something that happens over time that's horrible, that happens to the majority of the population. Now that's a very strange cutoff, don't you think, between aging and disease. Let's try another switching of the map upside down. let's imagine that all the people in this room are taken to another planet. Okay, sounds weird, but just go with me. And on that planet, people live to be 300 years. It's possible, okay? Now, what would happen as us, as collective individuals, as we started to get into our 80s, and if we're lucky into our 90s, we would get crippled, and, we couldn't play tennis anymore, it would be horrible. And the people on that planet, they'd send their doctors over and they'd say, boy, look at that group of people. Don't go near them, you might catch what they have, okay? So apparently, aging, it depends on the health and lifespan of your neighbors. So I'm here today to tell you that I believe very strongly that aging is a disease. Now, why would that be a big deal? Now, Aubrey's right. What this means is that if you think about aging as a disease, you actually work towards treating it. And that really makes a difference. In the NIH budget, okay, so it's many billions of dollars, 0.06% of the NIH budget is given to studying the basic biology of aging. And I think it's because most people don't think of aging as a disease. It's something natural, something that's supposed to happen. And God forbid we might overpopulate the planet, which, by the way, is not the case. It turns out if we were to stop aging right now, which we couldn't, but if we could, the rate of population growth would be less than the rate of immigration right now. But that's another discussion. But I want to talk about thinking differently about aging. So Aubrey used a similar analogy, and I'm going to take it one step further. I too agree that our bodies are machines, like this car that's worn out, but I think that this is an old view about aging and biology in general. It's the Newtonian view of humanity. What we've been missing for the past, well, up until about 20 years ago, was the fact that our bodies have extraordinary amount of self-repair, and Aubrey did mention this. But I'm going to tell you about the identification of the genes that actually control these repair processes. We call these things longevity genes. Okay, and there's a whole family of them. There's probably about 20 or more of major genes that control aging in simple organisms like worms and flies and yeast. And we find these genes in our bodies as well. And there's increasing evidence, I would say it's nearly indisputable, that these genes also control our health and how susceptible we are to diseases. Now, there's another reason for thinking that we might be able to tackle aging. And I think many of you have heard of this diet called caloric restriction. And lunch is coming up, so I hope I don't ruin it for anybody. But this diet is essentially you have about 40% fewer calories than what you would naturally be recommended. And this really means you have to be hungry for most of your day. Some people think it's likely to extend lifespan. It certainly works well in rats. It was shown back in 1935 that it delays aging tremendously. It's the best way we know to prevent cancer in animals. And it works in things like little worms and flies, even fish, spiders. And some people believe that it's going to work in humans. Now, we don't know if it will work. It's a long experiment. Unless we get tens of thousands of people doing this, which we haven't, we can't really test this easily. But some people do this. And I know Paul McLaughlin, he's the president of the Calorie Restriction Society. You can go online if you'd like to check out their recipes. Mostly it's salads. I tried it for about a week, by the way, and gave up. It's horrible. And they say that if it doesn't extend your lifespan, at least it'll feel that way. So I was involved in the early to mid-1990s at MIT as a young student in the lab of Lenny Guarente, and we were trying to understand why do organisms grow old and if we could do something about it. And in those days, working on aging was pretty much considered a career-ending maneuver. And I bet my PhD supervisor, thought he'd never hear from me again, because it really was crazy talk to be working on genes that control aging. But what actually happened was that the lab that I was in, Lenny Guarente's and others, like Cynthia Kenyon, Gary Ruvkin, these are all legends in the field now, they discovered that you can make a single genetic change in one single gene and double, in some cases triple the lifespan of an organism in the lab, like a worm or a yeast cell. And there's a group of genes that I work on, which became known as the Sirtuins. And they are shown in the next slide. They came originally from studies of yeast cells. So believe it or not, the little yeast that you sprinkle in your bread or when you make beer, these actually have a lifespan. They live about 20 divisions, which is about 10 days. And the goal was, in the 1990s, to figure out what are the genes that control how long they live. Now, we actually found a set of genes which I mentioned, called the Sirtuins. And those are the genes that I'm going to talk about today. The Sirtuins actually turn out to be part of a regulatory network within our bodies and in animal bodies and even within yeast that control the organism's health during times of adversity. So if you stress these yeast cells, and the one up there, the big yellow one, is an old yeast cell. The pH is low, so it's staining yellow. So if you stress these cells, these Sirtuin genes come on and protect the organism and make it live longer. And we now know that if you don't have these Sirtuin genes, calorie restriction, this diet doesn't work effectively. And in some cases, it doesn't work at all. So we really think that these Sirtuin genes are major players in mediating these health benefits of this diet, calorie restriction. Not just in yeast, but now we've seen it's true for worms and flies, and even mice. So what does this mean? It means actually that we have, first of all, a handle on how calorie restriction works. And it also means that once you understand how it works, you might be able to find ways to intervene. So here's just the paradigm that we have now. This is really a paradigm shift if Kuhn ever saw one. This is how we think that aging is regulated. Up the top is diet and exercise. If you don't eat, let's say overnight, you wake up in the morning, you have more Sirtuin activity. These genes are switched on. Conversely, if you eat a hamburger, I was going to say a company's product name, but if you eat a hamburger, you will temporarily, and if you get obese, for a long time, permanently turn off these longevity genes. So your diet actually controls these pathways. And our Western diet actually may be limiting our lifespan because of this. So really what we need to do is bring these genes up, activate them to bring us back to at least to a natural state, and maybe hyperactivate them to make us even healthier than we could ever be. And down the bottom you can see that the Sirtuins are slowing down the causes of aging. Now what's great about this, and I've been called an anti-intellectual for saying this, but I'm still going to say it, we don't need to know the causes of aging to be able to slow it down. And the reason is that we just need to target those blue guys and get them to do the work. And they are much smarter than we are. They have been around more than 1 billion years, taking care of organisms originally in the bog. And we find them in all life forms, in bacteria, in plants, in humans. In fact, we believe that the molecules that plants make, which I'm going to talk about, they make these molecules and we ingest them and we get the benefits of those signaling molecules. So wouldn't it be great if we could find a drug that could activate these longevity pathways like the Sirtuins? Finally, we had, at least in theory, a way of giving the benefits of diet and exercise without actually having to sweat or to go hungry. Sounds great, doesn't it? Well, this is what we embarked on in my lab at Harvard back in 2002. And we've made some inroads. We found that we could activate one of the Sirtuin molecules, called Sirtuin, with a molecule that actually comes from red wine. Okay, I think all of you, if not most of you, will have heard of this molecule. Its name is Resveratrol. This is one of the 20 molecules that we found at Harvard. It gets a lot of press because it's in red wine, but there are other activators that come from the plant world, and plants make them when they're stressed out or they're starving. We believe that when we ingest those plants, we get that signal of adversity in the environment. So we started feeding resveratrol. Well, let me show you. I made some models of resveratrol and some other molecules with my kids the other day. I'll show you one. Okay. So this is resveratrol. This is certainly not a life-size model. I did a back-of-the-envelope calculation that if this was the real size, the glass of wine would be about the size of San Diego. But it does exist. It's real. It's a white powder. And these are carbon atoms, and these are oxygens and hydrogens. And my kids had a great time. There was a lot of laughter when I said, "Kids, do you want to come help me paint my bowls?" They had a great... So I highly recommend this if you want to teach kids chemistry. So this is resveratrol. It actually, we believe, binds to the enzyme and activates it, which is something that's very rare in biology, actually, and it's still debated. But nevertheless, we fed this molecule to organisms like the yeast I showed you, and to little nematode worms that are about 1 millimeter long, to fruit flies. And without exception, they lived longer. And this lifespan extension required this gene, the Sirtuin gene. And so we were very excited. That was when we had a paper in 2003 in Nature, and the sales of red wine for that month went up by 30%. So then, of course, once we looked at simple organisms, we wanted to know, what about mammals? What about something that's furry? And so with a collaborator at NIH, Rafa de Cabo, we started feeding resveratrol to about 500 mice and waited to see what would happen. I thought maybe they would die. I mean, resveratrol wasn't known to be very safe, wasn't known to be safe in those days. But what happened was really surprising. What we found was that these mice stayed as healthy and had the physiology of a lean mouse. Okay? I was hoping that maybe they'd be slightly fitter, or, I don't know, their coats would look nice and shiny or something, but it really did work. We looked at the physiology of these mice. We looked at their hearts, we looked at their livers, their eyes, their bones. As far as the pathologists that looked at these organs could tell, these mice on the drug were as healthy as the ones that were on the lean diet. And so these mice that I'm showing you, the one on the left is the one that's on a very lean diet, and the one in the middle is eating a high caloric, basically an American diet. And then the one on the right is still fat, but it's taking resveratrol in its food. And it turns out that this mouse is extremely healthy as a result. Now, based on the mouse studies, these are some of the predictions of the diseases that might be able to be tackled by activating these longevity Sirtuin pathways. And there have been you could Google this or do a PubMed search. There are dozens and dozens of studies from around the world looking at not just resveratrol, but other activators of this pathway in things as different as neuroprotection to osteoporosis. I have a movie of what happened. This was unexpected, but Johann Ulbricht in Switzerland fed resveratrol to his mice. And these were on a normal diet. And you can try and guess which is the mouse on resveratrol. Can you tell? Actually, the one on the right looks better as well. But obviously, it's the one on the right. Turns out that if you do this on dozens of mice, they can run twice as far without ever having gotten tired. So there's a huge endurance effect as well. And when Johann's lab looked at the muscle of these mice, they were more like a Lance Armstrong. They had huge amounts of mitochondria, little power packs that make energy in muscle. So really, these were getting the benefits of exercise without ever having to exercise. And so Mark kindly mentioned a company that I co-founded in 2004 called Sirtuins Pharmaceuticals. I still consult there, but now Glaxo owns the company. They bought it, and I say this number because it shows how serious they are. They bought it for nearly $750 million with a B. And that number is astounding for any biotech company, but it's even more astounding for a company that works on aging. And really, a lot of colleagues in the field wrote to me or called me up and they said, finally, aging research has come of age when a large pharmaceutical company like GlaxoSmithKline will take a bet on aging research. And I sure hope it works out. Because if it doesn't, it may set us back a while in this field. But these guys, the guy on the left is Andrew Whitty, the CEO, and Moncef Slaoui, the head of research and development. They really have guts. But they do believe, and as I do, is if this works, you could really change medicine. I'm launching a non-profit site as part of this conference. This is not a promotion because it's non-profit and I'm just paying it out of my pocket, but this is a site that's designed to collect information and distribute information about resveratrol, because I get emails every day from people saying, how much should I take, where do I get it, and it's a real mess. You probably have seen me on the web maybe, up there with Dr. Oz and Barbara Walters. We don't endorse this product. We don't endorse any products, but I do want to educate the public, and that's one way to do that. And there's a free book that I wrote with a colleague of mine at Harvard, Mark Boguski. So what I do want to end with, in the last few seconds that I've got, is to tell you that we've gone a long way from red wine. Now, the media, I shouldn't say the media. Now, some reporters get excited about the red wine story. It's a good story, right? It's an excuse to drink red wine. But actually, GlaxoSmithKline and Sirtuins have taken this way beyond resveratrol. They now have molecules that are 1,000 times more potent. They've gone through animal studies. They work in diabetes and dry eye and cataracts, a whole list of things, even inflammatory bowel disease. The same molecule is working in all these different diseases, which I think is a first in medicine. We'll just see if they work in humans, and actually Glaxo has now pledged many tens of millions of dollars to run clinical trials in humans. The one that's biggest right now is in type 2 diabetes, not aging. That's not something they're interested in right yet. But type 2 diabetes is a trial that's ongoing throughout Europe and Russia. And we'll know over the next, well, I better not say because I'm not allowed to speak about timelines, but let's say in the next few years, we'll definitely know the results of these studies. Okay? And I think just if we take a quick step back, the idea that somebody could talk about an anti-aging drug that could be prescribed to a patient, say for type 2 diabetes, and you turn over the page and look at all the side effects. Side effects include, fewer cataracts, it'll protect you against heart disease, osteoporosis, and it may improve your sex life too. Are you okay with that? And I think that these drugs will eventually permeate society when they come on the market. They'll be much cheaper for the third world, developing world. The molecule looks like this. This is the drug. You can see it's not resveratrol. It's very different. It's very beautiful, actually. That's a sulfur atom up there in yellow. And this is the one that is in humans, or a very similar one is in humans, in people right now, to treat their disease. And I'm sure hoping it works, because it really could be a big deal for the world. And I want to thank you for your attention today and for inviting me.